So when we launch an object into the air, we call it a projectile. Projectiles travel in parabolas. They travel in a parabolic trajectory. You could analyze them with some of the stuff you learned in pre-calc 11. You could actually find the vertex. That would be the top. You could. It's much easier to use components, Danica. It really is. We're going to use vectors and components. We're going to break each projectile's velocity into its horizontal and vertical components. So here is a velocity, 24 meters per second at an angle of 36 degrees. I can't say north of east because north isn't up. North is towards the back of my classroom for those of you who are following. That's not north. So we would actually say 36 degrees above the horizontal is how we would describe that. Start on the horizon, you're launching 36 degrees above the horizon, but we don't say the horizon, we say the horizontal to make it sound, I don't know, somehow nerdier. It says break the following velocity vector into its vertical and horizontal components. So what did we say? We said you're going to draw arrows on the end. That's Vx. That's Vy initial. How come I put an initial on the Vy, but not on the Vx? Vx is constant because there's no horizontal acceleration if we ignore air resistance, which we've been doing our whole physics career. Yeah. There's a phrase that we say, the phrase that strikes the most terror in any physicist is include air resistance. Really? Okay. Color. Danica, what do you want? Oh, I guess I'm going to find Vx first because that's what they listed first. Danica, this 24, opposite adjacent to hypotenuse. Which one of those is correct? Yes. What about Vx? Which trig function? A and H? Yes, cosine. So it's going to look like this. Cosine of 36 equals adjacent over 24. How would I get the Vx by itself, Danica? Times by 24. So it's going to be 24 cos 36. I get a Vx of 19.4. You know, Mr. Duke, change colors just so it stands out a bit. 19.4 meters per second. Hey, Braden, that Vy initial opposite of I guess it's opposite, yes? I could technically use tangent to find Vy, but then I'm using an answer to find an answer. I think I would choose to use that. Which trig function? O and H? Sine. Sine. Good. It's going to be sine of 36 equals Vy initial over 24. I'm lazy, Braden. I usually just backspace and edit and change the cos to a sine because I would times the 24 over. And I get 14.1. Now, for both of these, if I knew I was using them, I would carry some extra sig figs, maybe 4 or 5 sig figs, just so that my final answer will be good to 3 sig figs. But here, I don't think I'm using them, so I'm just going to go 14.1 meters per second. Are those right? There will be a question on your test where I simply give you a slanty vector and I say find the components. So this page right here is a good study summary. This is everything we know about projectiles when I'm studying for my test page. In fact, these 2 little charts right here. Horizontal motion, Vx is constant because Ax is 0. Oh, that means that d equals Vit plus a half At squared. Well, since A is 0, it becomes dx equals Vxt. Oh, that also means, by the way, t equals dx over Vx. This one is much nicer. I can find time and I don't have to solve a quadratic because the squared term vanished. If they give me a horizontal range, Sarah, I smile and I say, this question's going to be way easier to find time than if they give me a vertical height. Trust me. So I wrote here, this means that if you know the time of flight, you can also find the horizontal distance called the range. Or if you know the range, you can find the time of flight. Horizontally, Vy is changing. Ay is constant. It's negative 9.8 meters per second squared. So, unfortunately, nothing cancels here. Specifically, the quadratic term does not vanish. The squared term will always be kicking around. If Vy initial is 0, then that term can vanish, yay, but it often won't. Some notes, remember we said at the very, very top for a split second, Vy is 0. Doesn't mean V overall is 0 because it's still moving sideways. In fact, Garrett, at the top for a split second, V overall is just Vx because that's all that's left. So does this mean that V equals 0? No. Just the horizontal, just the vertical component is 0. Also, something handy to have in your back pocket. If we start from the ground and end on the ground arch, what? Your initial and vertical velocities will be the same, but opposite. That's if I'm starting and ending in the same place. Okay? Oh, last thing. If you're starting from a cliff, the ground is below you, and so you have to make any height they give you negative because your vertical displacement, you are ending up below from where you started from. Mr. Duck, yeah, George. You said that projectiles travel in a parabola. Yeah. I've seen some projectiles that seem to wobble. Maybe a basketball that's been warped. When I spin it, it seems to wobble. Are you lying, Mr. Duick? No. Put your pencils down, look up. What I really should say is this. The center of mass of a projectile will always travel in a parabola. So this is a nice little demo from MIT. Notice how the tennis racket or the badminton racket seem to wobble a little bit. This one will really wobble. And then this disc really wobbles as well. And that's because its center of mass is not dead center. Now we're going to do the same objects under black lights, but this time the center of mass is painted orange, and you won't see them wobble because the center of mass will travel in a perfect parabola. That was the badminton racket. There was the wobbly little bowling ball looking thing. Or there's the tennis racket, I think. And then here's that disc that really, really wobbled. Now here's the center of the object. That'll wobble because the center of mass and the center are not the same location. But here's the center of mass. No wobble. So I should point out, you're correct. Objects can seem to wobble. We're going to assume all of our projectiles have the center of mass at the center of the projectile, no wobble. Once again, Danica, we're in our magic physics world. We're making some assumptions to make the math easy. The toughest projectiles are projectiles from cliffs at angles. We're going to spend most of our time finding time. Kevin, why is time so handy? Because it's a scalar. It can go in both columns in my t-table, and I need 3 things to find the fourth. It'll often be the third thing that I need to find. There's 3 strategies to find time. Strategy 1, you can find time to the top by letting Vy final be 0. Then you can find time to the very, very bottom by letting Vy initial be 0 and finding how far down it's going to fall. Meh. Strategy 2, you can do it all at once in one step. Ah! Of course, you know I'm leaning towards that one. Strategy 3, and find time to top. Mud, you can double that. That'll get you the time back to the cliff again. Then let your Vy initial be negative Vy, be negative what it was on the way up. Find how long it would take to fall the rest of the way, and then add all 3. However, if you find strategy 2 difficult, see me after school or after the lesson or during a flex, and I can show you one of the other strategies to see if you like it. But I just don't like finding 3 things or 2 things when I can just find one thing and get there in one step. However, it is going to require you to be able to solve a quadratic equation, either by hand using x equals negative b plus the square root of b squared minus 4ac all over 2a, or if you listened to your physics teacher and you got a good quadratic solver, you can use the solver. I like example 1, I like example 1, I like example 1. Example 1 is a nice question. David, why would I say that? Xavier, why would I say that? Did you hear me say it's going to be on the test, or you just notice when your teacher tends to emphasize certain things? Good. Got the hint, David? Yes? You're my newbie, so everyone else has seen this dance before. Well, it looks like we're being launched from a cliff at an angle. Did I say angle? I'm going to break this into components first thing. So I'm going to go d. There's Vx. d. There's Vy initial. Color. Okay. Adjacent, hypotenuse, opposite. Let's find Vy first. George, which trig function am I going to use to find Vy? Say that again. Not to make fun of you, but to make a point. Say that again. One more time. Vy was sine. What was Vy here? Which trig function? Which trig function was Vy here? Which trig function was Vy here? Mr. Duick, will Vy always be sine? If I give you that angle, which I always will? Yeah. Mr. Duick, have you got a stupid way that I can remember that Vy will be sine? Mr. Duick, do you have a dumb way that I can maybe remember that Vy is going to be sine? George, if I was a good teacher, I would have a dumb way that you could remember that Vy is going to be sine. I got nothing. You'll have to come up with something else on your own, I guess, and figure out some dumb way to remember that. So you're telling me Vy is going to be 50 sine 30 when I do the trig. Can you guess which trig function Vx is going to be? Of course you can. Of course you can. Yes? Okay, so if you're looking for a stupid hack, Vy will be sine, Vx will be cos. I think Vy works out bang even to 25, yes? Vx is going to be a decimal. $40.30. I'm going to carry some extra sig figs. I'll go 40.301. 43.301. By the way, Sarah, what did they ask me to find in part A? So I'm not being fussy with units or anything. I checked my units are good, but I'm not going to... units on my final answer, always. Is this a projectile? It is. Now I'm going to do a t-table. I'm going to do it kind of right about here, I think. I got some room sort of in the margin. Horizontal. Vertical. Sarah, what were the two things that I called my physics no-brainers that I can write right away? AX equals and AY equals. I didn't even look at the question. Now I'm going to look at the question. Oh, I guess I can say VX is 43.301. VY initial is 25. How come I put an initial on the VY but not on the VX? Because the VX is constant, not changing. And I want to remind myself of that so I'm not tempted to accidentally put an acceleration into there. Sarah, I think this was your dance last class as well. How many items do I have in the horizontal column? In the vertical column? 2. I need, oh, haven't used that yet. Except, why would writing this be wrong? Why would it be wrong to write dy as 60? Negative 60. And unfortunately, that you will have to catch. Mason, you might get an actual, sometimes you'll get an error on your calculator. You did in Physics 11. You always got an error if you missed that. Physics 12, the quadratic equation, because you have two solutions, one positive, one negative, you'll probably still get a solution if you miss that negative. Sarah, which column do I know T things in? T things in, that's, three things in. I'm going to solve for T vertically. So I'll put a little T equals question mark. Looking for an equation that's got an A, a VI, a D, and a T in it. There is one. Our old friend. D equals VIT plus a half A T squared. And Paige, what we learned last day was, unfortunately here, because none of these are 0, I can't get the T by itself using formula manipulation. This is a full quadratic equation from Math 11. I'm going to put in my numbers. It's going to be negative 60 equals 25T minus 4.9 T squared. I did the half of negative 9.8 in my head. I've done that one often enough that I can handle that. Hey everyone, what kind of an equation is this? It's a quadratic. How do you know? Just by glancing at it. It's got a squared. What was step 0 to solve a quadratic? And yeah, that's your hint. I always taught my kids step 0, make it equal to 0. Before you start, you got to make it equal to 0. I could plus the 60 over. I'm actually going to plus the 4.9 and minus the 25t, because I've learned I make more dumb mistakes when the quadratic term is negative. So it's me being uber paranoid. I'll get positive 4.9 t squared, take away 25t, take away 60 equals 0. And I also wrote it in the correct order of descending power. So that's A, that's B, that's C. Those of you that have the quadratic solvers, once you've written this, you can go straight to your built-in quadratic solver, and I'm good with that. How many of you don't have a quadratic solver? Raise your hand. So those of us that don't, here we go. We need the quadratic formula. Now, normally it's x equals negative b. It's on your formula sheet page. I gave you the blue formula sheet, right? So instead of x equals, I'm going to write t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's going to be negative b, well, negative 25 is positive 25, plus or minus the square root of negative 25 squared minus 4 times positive 4.9 times negative 25 No, negative 60, Mr. Dewick. Sheesh. All over 9.8. I had a student last year who actually derived this algebraically and said, hey, Mr. Dewick, is this just a generic equation for finding time? Yes, it is. I think it was you, as a matter of fact, who did that. It's like, yeah, clever boy. When I was in not high school, when I was in college, I had a programmable calculator, and so I wrote a piece of software that would just solve projectiles for me. And I showed it to my prof, told him I'd written it, and he said, yeah, you can use that on the test. If you can code it, you really have to understand how it works to code it properly. So sure. Okay, time to get my calculator out. Paige, is this a fraction? Yeah. Brackets around the top. 25 plus square root, open a bracket. And then Paige, you've had me long enough to know I'm lazy but organized, okay? What's negative squared? What's going to happen to that negative in front of the 25 when I square it? I'm not even going to bother typing it because that's going to require me to do brackets. I'm going to type positive 25 squared because I know that's the same answer, and I'm lazy. Minus 4 times 4.9 times negative 60. Close off the square root. Close off the top. Divided by, and since there's only one thing on the bottom, I don't need brackets around the bottom. Do you get 6.881479995? Yes? I'm going to write down to like 5 sig figs and then I'll round off because I know I'm going to be using this for part B. T equals 6.8814. And then there's going to be another one if I backspace and edit and change the plus sign to a minus sign. Negative 1.779. Mason, which one of these do I reject? Yep, much like you trying to dunk, right? Reject. Okay, I guess since they wanted me to find time, I'll report it to 3 sig figs for my final answer. I'll put the units next to it. I'll draw a box around it. This projectile is going to be in the air for 6.88 seconds, but here's the other bonus, George. I now have something that goes in both columns. I now know 3 things over on the horizontal column. I can find the 4th if you want to. In fact, I'm willing to bet, Taryn, is there a part B? Yeah. And I bet you it says find the range. You notice I didn't give you as much room because we spent most of our time finding time. To find the range, range is horizontal. Range is going to be dx, and it's just going to be vxt. What happened to the plus a half at squared? So why write it? Vx was something, 43.301. Time was, I'm going to write 6.88, but you all know I'm using my answer button, right? 43.301 times, oh, I can't use my answer button. Okay, what was it, Mr. Dewick? 8814. And I get a horizontal range of 297.9, you know what, 298 if I round off properly. Meters. What else could I ask you to find? Time to reach the top. Wait a minute. Can't I just go 6.8814 divided by 2? Isn't that the time to the top? Nick, why not? I think the phrase that you're looking for is, it's not symmetrical. Unlike from the ground to the ground, where you can split it in half exactly, Here, it's going up for less time than it's going down. And so I can't just go, oh, time to top is halfway. Okay. Time to what? Vertical. The word top implies that. Okay. Let's make my list. It wants me to find time. Vy initial was 25. Ay was negative 9.8. What else do I know at the top? What's VF? I gotta be fussy. No, it's not. Vy final is 0. But you know what VF actually is? Vx, because that's all that's left. Gotta be really fussy and careful. I'm also dropping you a hint about that question. Okay. Anyways, Vy final is 0. Oh! Now this is physics 11. I think T is going to be Vf minus Vi over A. I'll just make sure everything in there is vertical. Don't you dare put a horizontal into a vertical. It's going to be 0 minus 25 divided by negative 9.8. Whoop. There we go. Oh, I got wonkiness going on there. Try that again. And I get 2.55 seconds. D is tough. D is tough. Especially if you're texting on your phone. Then D is really tough. Right? Right. Hey, Mud, what does D want me to find? Isn't it 0? No! Do a belly flop off of your desk onto the cement. I assure you it will hurt. What does it want me to find? Say it again. Impact velocity. I don't know. Oh, you know what, though? I know what it looks like. I think the impact velocity hits the ground at an angle. Did I say angle? Draw that, because that's what I think it looks like. There's my dult. But I'm going to break it up into components. Where this is the whole... Oh, wait a minute. I know Vx, because that hasn't changed. It was 40 something, 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 something. Was it 43.301? What about Vy? Is it negative 25? No, that would be right when we pass the cliff again. We're going down at negative 25, but then we kept going. I think I need to figure it out. So I'm going to make a little note in the margin over here. Vy final equals question mark. Ooh, what was Vy initial? 25? What was Ay? You know, if I knew one more thing, I could find the fourth. What else do I know? Did we hit Vy final? Did we hit the ground? Is our impact after exactly 6.88 seconds? Yeah. I can use T equals, I'll use the 5 sig fig version, 6.8814. Or I could have used the dy of negative whatever it was, 60, I think. That would also get me there, but this gets me there a little cleaner. Because I'm looking for an equation that's got a VF, a VI, an A, and a T in it. There is one. It's VF equals VI plus AT. Just make sure everything is vertical, 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 vertical. It's going to be positive 25 plus negative 9.8 times 6.8814. Ah! I got a negative answer. Did you get a negative answer? Oh, wait a minute. What direction are we traveling vertically when we hit the ground? I'm not nervous now. I was hoping for a negative answer. Did y'all get negative 42.43772? That there? Negative 42.438. And so I can put that on my diagram, 42.438. Mr. Duke, where's the negative? Psst. Right here in the arrow pointing down. That contains the negative because down. This right here, the slanty side, Danica, the hypotenuse. That's what I want to find. Garrett, how could I find the magnitude of the hypotenuse if I know two sides? Looking for a word that starts with letter P and rhymes with Pythagoras. Pythagoras, okay? So the impact velocity is going to be 43.301 squared plus, answer button squared, square root answer button. And I get 60.629. Now this is my final answer. I'll go to 3 sig fig, 60.6. Are we done? Are we done? Why aren't we done yet? Because all vectors have both magnitude and what? Got to give a direction. Now, if they had said find the impact speed, walk away, I'm done. Because that is the impact speed, 60.6. They want the direction. Where's theta going to go? Top left or bottom right? Color, 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 color. Danica, that Vx, opposite adjacent to hypotenuse. Now you're back. Good. What about Vy? Which trig function to find theta? O and A. Tan theta equals opposite 42.438 over 43. Before you go to your calculator, by the way, Owen, is 42.4 and 43.3, are they fairly close together? This is almost, but not quite, an isosceles triangle. I'll bet you get something really close to 45 degrees, because this is almost a 45-degree triangle. Not quite. But you're either going to get 46 point something or 44 point something. I'm almost positive. So a bit of a built-in error check specifically for this unique question. Let's find out, Mr. D. $44.4? Yeah, I told you. At 44.4 degrees. And we would describe this as being below the horizontal. Now, Karen, if you said south of east, I'll give you full marks, but I'll also probably write a little frowny face next to it because that beneath us isn't south. It's below. South is the front of my classroom. Point south. Is that all right? Okay, that's cliff at an angle. Did I say angle? Components. Ugh, quadratic formula. Example 2 says find the range. Okay. How am I going to start? Even before T-table. How do you know components? Do I see angle? Components. So you know what? This one's a bit awkward. I'm going to redraw it because I don't like where that 35 is and how it's drawn. So I'm going to go like this. Make it a bit bigger. Yoink. Vx, Vy initial, 35 degrees. No, not 35 degrees, Mr. Duke. 20 degrees, 35 meters per second, color. Now I'll go T-table. Mr. Duke, don't you want to calculate the components? Patience. X, Y, AX is 0, AY negative 9.8. Anybody tell me, can they remember, what was VY? Was it really? VY initial is going to be 35 sine 20. Oh, that's a typo. And I get 11.9707. How about, yeah, sure. We'll go to 6 sig figs. 11.9707. Now what? Vx. Well, if Vy was sine, which trig function is Vx going to be? Of course it is. And I can just backspace and edit. And I get 32.889. Which column do I know 3 things in? Nothing yet. Let's look at the picture or the question. What else have they told me? Ooh! Vertical displacement or horizontal displacement? So you're telling me dy, what does dy equal? Negative 20. I think I'm going to find time vertically. Before we go further, look up. What if instead of giving me the vertical height, what if they give me the range? Oh, it would be so much easier because you'd still know 3 things. You can find time. Because a is 0, your quadratic term vanishes. Time is just dx over vx, and you're done. So I think there's one on the homework where I give you the range. It's just a lot easier because there's no quadratic formula required. Speaking of quadratic formula, d equals VIT plus a half AT squared, vertical, vertical, vertical. So, negative 20, 11.97 U1L7 T minus 4.9 T squared. Solve that quadratic on your own for T. David, have you seen the quadratic formula before, or do you use a method that involves P's and Q's? Okay, okay. Because there's at least 2 or 3 other ways to solve a quadratic. Really? Yeah. Well, big time typo there, Mr. Duke. Close off the square root, close off the top. Divided by 9.8. I made a typo, but I think I fixed it. You get 3.5823674 for, okay? I'll go 3.5824. And just double check to make sure there isn't a second positive root. Shouldn't be. Negative 1.39, negative 1.139. Am I done? No. Because what did they ask me to find? That's going to be dx equals vxt plus, oh wait, no, just vxt. No half at squared. What was vx? 32.889. What was t? 3.5824. And I get 118 meters. Is that right? People nodding? $118 meters. Planning my attack here. And I think what I'm going to do is pause temporarily here and give you some cliffs at angles to practice. So if you want to get a head start on the homework, first of all, finish the stuff up from last day. But number 1 is good. Three is good. Six is good. 7 is good. 8 is good. 9 is good. Eventually, I'm going to assign number 10, so you can try it. 11 is a nasty. I think I'll pass and pause. So you can try some of those from the homework. There's nothing there that I haven't covered. I just haven't done as many examples with you as I'd like. Then also tomorrow or Wednesday, you can expect a take-home quiz on kind of everything. Okay.